Well, hello, and welcome to the Train Buddy Shop once again. We've got an interesting situation here. This is a Broadway Limited engine, and this is a Paragon 3 sound system. And one of the ways you can tell that it's a Paragon 3 is that it has this loop and this other piece in here, which is actually a transmitter, right, for the Paragon 3. What do they call that? Wow sound? No. I'll find out. Hold on. Rolling Thunder. The Rolling Thunder system transmits to a receiver, and so here's the Rolling Thunder receiver from Broadway Limited. You can see our price on there, typically about $100. The receiver itself, plugs into a system. Now you can either purchase their subwoofer, so they have a subwoofer that you can use, which you can dial in the actual filter and at what value frequency, right, it dies on. In other words, you want low frequencies coming through this, or you can hook it up to your stereo, and so it's got all the plugs to do that kind of thing, if you have a stereo like we do here in the shop. Anyways, this young fellow decided that he doesn't like the sound. He didn't like the sound at all coming out of this particular system. And so he wants to remove this altogether and put in a Tsunami 2 digital sound decoder. And again, we are delighted to carry Tsunami and Soundtrax decoders. And in this case, we're going to replace this. So we're going to talk a little bit about how we're going to go about that. Notice that there's nothing but wires on this. All right. There are two speakers that are already integrated into this. This is the tender, by the way, of this particular locomotive. So there's two speakers there, and we're going to use those two speakers. We're going to check to make sure that we're not overburdening this sound system. There are other things that are associated with this Paragon 3 Broadway Limited engine that we may have to adjust for. It does have a chuff circuit in it, and so we may find that we're going to have to adapt the chuff circuit. Tsunamis all have chuff circuits capability, and so the white wire typically coming out of the back of this is that circuit. So we're going to unbox this or unpackage this and take a look at the innards of this and start marking out which ones go to the motor and which ones go to the speaker and this, that, and the other thing. And before we go any farther with this. So let's pause for a moment till we get a cup of coffee and get ready to do that. Okay then, so I've taken the decoder out from the BLI decoder, and here we have what's left of the tender. There's some obvious connections here. The obvious connections are that these two go to the speaker, and usually red means positive and black means negative, but in this particular case it's not really relevant because these two are already connected together. Typically you would do, if you have two speakers, you do plus to minus, and then it doesn't matter what's going on here as long as the two speakers are going in the same direction in and out. Then the sound won't cancel each other out. If you do plus to plus and minus minus to minus, you get a totally different ohmage coming out of here, or impedance it's called, right? You can measure it on the ohm meter, but it's the impedance that we're trying to match with the output of the analog amplifier that's inside of the decoder. These two wires, one goes to one truck and the other one goes to the other truck. Whether or not it's right rail or left rail depends upon where the insulators are, and typically the insulators on one side are on one side of the locomotive or the truck. So in this case, it looks like the insulator is here. It's hard to see there, but there's an insulator right there, and then on this one, the insulators are on this side. Okay, so it's picking up from this side for here, and it's picking up on this side for here. It goes through the wheel, goes through the axle, right, and then goes up through and inside. So we'll test that out later when we get there. Something fell off. A little bushing fell off. Oh, look, there's two little bushings that were standoffs for the decoder. Okay, so now what we need to do, we're going to set this aside for a moment, and what we need to do is we need to determine with the plugs that are here, so I've replugged it back up to the locomotive, we have to now test out, since there is no documentation, well, I imagine somebody has some documentation somewhere, but we can actually create documentation while we're at this, because this may not be the last time that we ever do this kind of locomotive. So what we want to do is we want to test out the plugs. Well, it's really hard to do that with the probes that we have for this meter, and so we can create a probe. I'm just using a little pickup. Make sure I get the right one, right? Make sure I get the right wire. A little alligator clip and a wire, and a real sharp pointed object. Now you can use just about anything. You can use an old straight pin if you have to, and we're going to then probe which wheel and which whatever. So we can start with the wheels because they're the easiest ones to do. And if we look inside here, do we have pickups on the wheels? We have to shine a light down in there. Let's see if we got a light that we can shine. Oh yeah, there we go. Well, I don't see any wheel pickups. Usually there are some. I'm getting down in there real close, looking for wheel pickups. Don't see any. Interesting. Usually you want to be able to pick up on every wheel. This may be a deficiency. Maybe a design deficiency as far as I'm concerned. Now, interestingly enough, as we look at this one, this wheel, this outside wheel here, has got an insulator on it. This side does not, but that would have to be the case because we want them to be insulated. The two rails have to be insulated. And on these, it looks like there may be even a plastic insert. Now, there might be pickups somewhere. I just don't see any pickups at all on this engine. That is rather strange. Rather strange. Okay then. Well, I guess I'm not going to test for that because there aren't any. Wow. And even on the back wheels, there's no pickup. That is, for the price of this engine, that is remarkable. Oh, well, there might be. No, it doesn't look like it. Wow. Okay. Well then, we're going to have to take another tact at this. We're not going to be able to test for that, but we're going to have to test for the motor. So we've got how many wires here? I'm pretty sure, since I've done this on another engine, I'm pretty sure that this is the pickup for the chuff. And so this would go to the white wire. So I'm going to hold that one out because I know that's probably the case. Now, a couple of these wires, so we've got 6 other wires here. I would have thought that that 2 of these, well, I know 2 of these have to go to the motor. So we can kind of try and figure that one out by just applying power and see what we get. 2 of these are going to go to the front light, and we know that's the case. The other 2 I thought were going to be the pickups from the front wheels, but evidently not. So what does that mean the other 2 are? Well, they could be marker lights. So these 4 could be the marker lights, and front light. Then these 2 could be the motor, and so we're going to play that game and see what we're going to do. I'm going to go ahead and apply power then to these 2, and I'm going to do it with a resistor, because if these 2 are in fact a headlight or a marker light, we don't want to burn them out if in fact the resistor is on the board, which in lots of cases they are. And we'll just see if we apply power even with the resistor, we should be able to get the motor to move, and if it does, then we know it's the motor current. So I'm going to forego then the meter and anything that we were going to do there for the moment. I guess I could probe these, thinking about this, I could go ahead and probe these, and we could test, of course I'd have to have another pointy object. We could test the leads to see what the resistance is, and that would tell us whether or not it is an LED or a motor. That would probably be safest, and then we can test it after we have tested the resistance here. So I think I'm going to do that. Let me find another pointy object here. I may even find a female for this, and then be able to pull the wires off, and then we can just clip directly to it. All right, so give me a chance to look for that. Okay, so I typically keep the cut-off ends of resistors and things that I use, and so I've got a pile of those, and I'm going to try this one that's got 2 pins, and we're just going to stick these in the ends of these 2 pins. It doesn't look like it's going to go. They're actually too big, believe it or not. So let me regroup and see if there's something else I can do. Okay, so while we were gone, I cheated a little bit. I couldn't find any pins that matched. So I found some really small wire, and I used solid wire, thinking that I could put these in the pins, and they actually worked. So I was able to go through and plug these in. I'm not going to do it now because it takes a lot of patience here. But you plug those in, and I measured all of the continuities between all of these different plugs. Well, it turned out that the only thing that had any kind of a semblance, this particular meter will do diodes. So if I thought if there was some LEDs, I could put it on diode and check that. I didn't see any of that. But what I did see was I saw that the 2 pins on this 4-pin connector had like almost 200 ohms between the first 2 pins. So I said, So I went ahead and took my meter, or my bench power supply. So I have a bench power supply. Now it's not a switching power supply, but it's a real bench power supply. Then I can adjust the current. So I thought, you know what, if it really mess up here and I have the wrong values for this, this is not going to work well. So I said, well, I'll plug this in and I will adjust the current, the voltage first for like 2 volts, and I'll adjust the current just as low as it can go. And that way, if it in fact is and I'm going to recreate the experiment here. If it in fact is an LED, it won't blow the LED up. LEDs being about 20 milliamps is all they can take. And so I have a current limiting power supply. And again, this is about $100, and you can buy it like I do at a shop. Anyway, so there you go. I plugged it in, and I'm going to go to 2 volts. I'm going to go to 2 volts here. All right, and nothing is happening. Why is it not happening? Oh, because I've limited the current. There you go. And now you see the motor is going, and it's going in the right direction for forward. Okay, so you see that that's happening there. And it's only about 2 volts, which means that this is a very, very efficient motor, and everything's right. And so what I did was I marked, see, see, I didn't show this to you because I didn't want to show you that I'd already done it. But I marked then this connector, all right? So bring it, and try to focus on the connector. So then I marked the connector. Let's get it in the focus here. M, right, for motor, and kind of a plus and a kind of minus there, right? So kind of plus and kind of minus. And what I'm going to do then is I'm going to go ahead and cut these 2 wires out, and I'm going to mark them. And I'm going to mark them as they would be on the decoder. The plus and minus to motor is going to be orange for plus, and gray for minus. And we'll mark those on the wires, and then we'll connect those into the actual decoder. Pull the decoder out here. I get the engine stuck on it. We'll do the decoder, and of course we've got the NMRA standard wiring here in the gray and the orange wire right there. So we're ready to go with that. Let me pull out the zoom again. Let's get back out to normal, and we'll continue on. I'm assuming then that the other 2 that are there are either for the smoke unit or for an LED, and that these 2 would be LED or smoke, right? And that the separate one, the one that's by itself, is typically for the chuff unit. So it tells us when we get top dead of center, or one rotation of a wheel. So it's one quarter of that for chuff. Alrighty then. So I'm going to go away again and test out some more of those and come back with some interesting results, I hope. Alrighty then. So I found this piece of description on the net, and I've printed it out. I would like to attribute this to somebody. It looks like it would be a BLI internal document that talks about the different locomotives and how they're wired with this board. Here's the board. Okay, remember that we took out, and the board itself. If I orient it this way, there's the P2. And as I look at the box that it came in, this is a Paragon. It doesn't say Paragon 2. That would be a P2. Definitely not a blue line, as it shows up above here. So this is right, but the orientation of it is backwards. This is the rear. This is the front. So the locomotive would be out here somewhere. I'm gonna then mark this up then with these and the harness. So here's the harness I've been fooling with, trying to figure out what's what. But now that I have this, I think I can get a better sight on what's going on. One of the things that we already know then now is that these are motor plus and minus, and I'll trace those through and figure out which connector they go on and all the rest of that. And I'm going to mark this one up for not only for the customer but also for us here as we go through figuring out which it is. It's not this, and it's not this, and it's not this, and it's not this. It's not a blue line, so it's none of these. So it's either this, the 3751 P2, or the GS4 P2. And I suspect that as we looked at pins, right, that the J program, PRGRM1, had one pin on it, so that it becomes negative. Now why we need that, I don't know. Reed switch here doesn't appear to show on anything. That would be J8. There would be 4 connections, unless, and it would be a 5-pin, and I don't think there was a 5-pin anywhere. That might have been a 5-pin. It looks like it's 6. So let me go through that and see what's going on. Yeah, this J4 was tender trucks, or J5 was tender trucks. Depends on which one. Loco driver, motor. So that's, both of these are the same, and that's this one that we just talked about. And then red and black for speaker, yes. And so the one that has got 2 pins, the one who's got 2 pins, is rear light. Rear light. Really? There's a rear light? Okay, well, alrighty then. Maybe so. Rear light. I'm not quite sure what that means. Unless there's one in a cab. Maybe it's a cab light. It says rear light on this. All right. Well, let me figure that out, and then we'll be back. Okay, so I'm working through some of the combinations, and I've got 2 of these sheets. One that's I'm starting to mark up here, and it's obviously not any of these or this one. It could be one of these 2. But these were both for Paragon 2. This is a Paragon 3 engine because it's got the one way you can tell is not, I don't know if they're all blue or not, but this wire is the antenna for Paragon 3, and this is still a Paragon 2 type format. So based on that and looking at some of these that are here, it matches this pretty well. But it is just not a Paragon 2, it's Paragon 3. So we're going to, again, look through this. Down here at the bottom, and I'm going to bring this up close so we can look at it here, is a BLI with P2, and it describes the 8 pins. Now, in this particular case, there's only 7. Okay, so there's one not there. It talks about right and left track, and as we looked at it earlier, it didn't appear as though there was anything that was touching the wheels or how they were connected. So I said, well, I've got the motors; those come out right. Track leads, I was just going to measure continuity. And continuity on this is just, it does a beep, right? But it's also the ohms. So I've got one of these connected, and I'm going to test, right, with the probe now, which one it is. And as I touch the wheels, I realize this one has rubber on it. It's got a rubber traction tire, so it doesn't going to do anything. This doesn't appear to do anything. This one kind of, it does beep if I push it one way, and the other one doesn't. So this one evidently has got something on it, but I'm not quite sure what, and we may have to lube that up a little bit. But definitely it is from the right tire. Okay, and then if I do these wheels, right? It's hard to imagine this, but oh yeah, look here, see, it's got a right and left. It looks like it's got a split frame in it, right? So a split frame is how it's working. Yeah, there you go. Split frame. Okay. So all of the tires should do that. Yeah, they don't. Well, this kind of does. Look there. Yeah, it kind of does. And this too, if it was right. Okay, so we know that this one, which is the third one on this one, is the right. Yes, or right. And we assume, therefore, that the other one is the left, but we're not going to make any assumptions. We're just going to test it. I'm going to test it. So I'm pushing that wire in that last one, and it should be on this side, and it is. Okay. So we're verified that, in fact, that's the case. And again, down here in the bottom, see, it works on that side, doesn't work on this side, so on this split frame. Alrighty then, we are good to go. We've got right and left. We've got motor plus, motor minus. Now let's go after what's left here. I'm going to kind of ignore, some of this, but because again, we've got the two outside and we've got the two inside, and then we got a positive 3.3 volts. So that would be the one that would be the plus, or the would be the blue wire typically. And if we look up in through here, we're looking for blue, right? Blue, 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 blue. So that would be the 2 wire. So the 2 wires got four pins, right? And it's got 2 of them that are connected towards the one side. So the blue is the inside, the red is the outside. It doesn't matter whether it's this one or this one, right? Doesn't matter, right? Doesn't matter. So we know the speakers. Now we've got this one, local driver, left and right, motor. Tender trucks are there. Now whether it's on this one or this one doesn't matter, but we got we got gray and blue. So yeah, we got gray and black on this one. Okay. No connection. And then the final one has got 1 pin. So there's only 1 pin. So now we're almost home here. All right. We got 1 pin, and this 1 pin would be negative. Right? Be negative. Yeah, it can be reed switch. If it's reed switch, then it is for the light. Now this one up here says rear light. So we don't have a rear light on this. I'm thinking this is going to be plus 3 volts and something. So again, this is not necessarily indicative, but negative and negative here implies that these are going to be the what we call the chuff circuit. Okay, so we're gonna test that out and see if that's not the case there. All right, looks like we're pretty much home and ready to cut this up. Again, I'm going to test the light, so we'll come back and we'll look at that in just a minute. Okay, so ordinarily I wouldn't do this because you'd see all the hairs and stuff. Anyways, as you look at the locomotive, this is the front light, also referred to as FOF, forward, I don't know, lamp. But what I've done is I've connected in, as you can see here, to that 4-pin connector, and I've got red and black coming from the power supply, and the red and black in that orientation. Ordinarily, I would put the resistor on the negative. So it looked like we had, based upon this, that the positive actually up in right here yeah, right here, the positive would be the outside lead. And as we've got it set up here, positive, green, 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 goes to the outside lead. Yes. Okay. So based on that, then this should come on. So when we turn the voltage up, and sure enough, there it comes on. Now, if you notice, I put a 1,000 ohm resistor on there. I wanted to make sure that there wasn't one inside of the locomotive. That means that we need to put a resistor on this lead before we send it out to the locomotive. So now we know plus and minus on the LED, and we have confirmed now that we've got LED, right, front light. We've got the 4 pins, these 4 pins, which go to the motor and to the wheels, all right, to the right and left rail. And then this one is, I'm going to say chuff circuit. Unless we run the locomotive and then test this for pulse, 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 we won't know. All right.